Good morning, everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today, I am going to tell a few topics on earthing system. Like, what is an earthing system? What are the different types of earthing system? Like plate earthing, pipe earthing, strip earthing, and their comparison. What is an earthing system? What is earthing system? An earthing system is also known as grounding system. It is also known as grounding system, which connects a part of electrical power supply to the ground. Part of the electrical supply which is being connected to the ground for safety as well as functionality. For safety as well as functionality, we will be connecting the neutral wire to the ground for safety purposes. So, earthing system protect people from electrical shock by providing a path for fault currents. Like if any type of fault occurs in the circuit, so the fault current will be sent through the ground so that the shock will not occur. So, here you can see for electrical shock, by providing a path of fault currents to flow to the ground. This also causes a protective device like a fuse or a circuit device or a circuit breaker. Means fuse as well as circuit breakers are also protective devices. In the same manner, the earthing system is also one kind of protection device. It is also used to switch off the electrical power during the fault condition. So, in a brief, earthing system is also called as grounding system, where the wire is being connected to the ground. If at all any kind of fault occurs in the system, the fault current flows through the ground. So, types of earthing system. What are the different types of earthing system? As I told, different types are like plate earthing, pipe earthing, and strip earthing. Here you can see three different types of earthings, that is plate earthing, pipe earthing, and strip earthing. What is plate earthing? A plate earthing is a copper or galvanized steel. That means a plate is being used for earthing, which is mostly made up of a material like copper or galvanized steel, which is being buried in the ground. That means the copper or galvanized steel plate type material is being buried inside the ground at a depth of about 3 meters. That is, inside the earth at a length of 3 meters, at a depth of 3 meters, we will be placing this copper or galvanized steel plate. And this method is common, but it may not work. May not work well in areas like high soil resistance. Means this also depends upon the resistance of the soil. So first, basically we need to measure the resistance of the soil, and based on the resistance of the soil, we need to place the plate earthing. And it also requires a lot of space and can harm the environment. So it requires a lot of space and it can be harm for environment, and it depends upon the soil resistance also. So these are the different drawbacks of a plate earthing. The second type is pipe earthing. Pipe earthing, it is a 38 millimeter diameter pipe. It is nothing but a pipe, a small pipe with a diameter of 38 millimeter, that is 2 meters long. The length is 2 meters long and the diameter is 38 mm, that is millimeter, is vertically embedded inside the ground. Here also the plate is being buried here, and instead of plate, this time we are using pipe with a 38 mm diameter and 2 meters of length, which is placed inside the ground to act as an earth electrode. Here this pipe acts as an earth electrode. The third type is strip earthing. In this strip earthing also we will be using copper or galvanized iron or steel. Same as your plate earthing, here also the same type of material, that is copper or galvanized iron or steel strip. Now here this is a pipe. Here this is a pipe. Now instead of pipe we will be using a strip here. Instead of pipe we will be using a strip here, and that strip is also made up of the same material and it is also buried inside in horizontal stretches and at least 0.5 meters deep. That is, if this is the layer of the earth, inside minimum 0.5 meters depth we need to place these strip here. Okay, so these are the three different types of earthing systems. We will know these three types in depth now. Like, first one is plate earthing. See, the plate earthing, it is a traditional method. It is a traditional method of grounding the electrical system, as we have already seen, by burying it a metal plate inside the ground. That is a metal plate. Previously I already told you that the plate is made up of copper or galvanized steel or iron. Copper or galvanized steel or iron, this type of material which is being shaped like a plate is being buried inside the earth or inside the ground. The plate acts as a conductor. It acts like a conductor, providing a low resistance path. For electrical current to flow into the ground. So whenever if any fault occurs, the fault current is connected to the ground and that current flows through the ground via this plate, because this plate is a good conductor and the current flows through the plate from this ground in order to prevent the electrical shock. So, mostly it provides a low resistance path. It provides a low resistance path for electrical circuit to flow of the current into the ground to in the event of electrical issues. That is, if there is any electrical issue or any kind of fault, this is used. So, here are some of the details of the plate earthing. Like, the first one is materials. The plate is typically made up of copper or galvanized steel or galvanized iron. The second one is size. The size of the plate depends upon the type of the soil. So, as I said, first we should measure the soil resistance, which type of soil is that, and based on the resistance we need to decide the size of the plate. that is to be grounded. And other factors also are there. Few of the other factors, I'll be discussing them. Like the third one is depth. The plate should be buried at least 3 meters, that is 10 feet from the ground level. If it is, this is the ground level, below this at least minimum of 3 meters should be there. Okay, 3 meters below only we can place this plate, copper plate or galvanized steel plate. So, the fourth one, next one is applications. The plate earthing is used in power stations, mostly used in power stations, transmission lines and large electrical panels. It is used in power stations, transmission lines and large electrical panels and high voltage transformers also. It is mostly used for high voltage transformers. It is used for large electrical panels. It is used in transmission lines and power stations. What are the advantages? What are the advantages of this plate earthing? Plate earthing can carry a high current, and provides good conductivity between the earth conductors and the ground. So it is placed between the earth conductor and the ground, and it carries a very good quantity of high current, so to protect us from the shocks during the fault conditions. What are the disadvantages? The disadvantages are, it is costly and requires regular maintenance. It is very costly and it requires regular maintenance. This is the one of the drawback of plate earthing. So, this is the plate earthing. The next type is, here you can see the picture of a plate earthing. Here you can see a plate here. This is called the earthing plate. The earthing plate is being placed with this salt, coal or sand material. This material inside this is being filled with salt, coal and sand. Inside this salt, coal or sand material, we will be placing this earthing plate, and this should be minimum 3 meters to 10 feet depth inside the ground level. This is the main ground level. This is the ground level. Below the ground level, 3 feet minimum should be maintained, and below this 3 feet, we need to place a salt or coal material, and inside that salt or coal material, we need to place this electrical earthing plate. So, here you can see this is being filled with water here. Here you can see a funnel, and this water is being closed here with concrete. This is being closed with concrete here. Okay, and here you can see the conductors, earthing conductors. These are the earthing conductors. So in a brief, this is the grounding level, and below this grounding level we need to place the water, and the water is being covered with concrete here, and to this concrete we are connecting the earthing conductors, and this earthing conductor is placed here into the salt or core material, and inside this salt or core material we are placing here the earthing plate. So this is the picture of an plate earthing. To install this plate earthing, you can select a flat open area which is free from obstacles. That is, it should be an open area without any trees or plants or any obstacles, and any vegetation and debris from the area. Dig a hole deep inside. We should dig a hole deep inside to bury all these plates, salt, concrete as well as water. So for placing all these, first we need to dig it and place the plate into the hole. First we should place the plate into the hole, making sure about the depth or the length, and first we should place the plate and compact the soil around the plate. Means after placing the plate, we need to compactly close the plate with this salt, coal or sand material, and after that we need to connect these conductors as well as this concrete system, and this water should be poured. So this is the construction of a plate earthing. Next one is pipe earthing. What is pipe earthing? Pipe earthing is a safety method. It is a safety method that involves burying of personalized galvanized steel. See, here also the pipe earthing is also made up of the material like galvanized steel only, and which is placed underground to connect the electrical conductors, which is being connected to the electrical conductors inside the earth. So it's a cost effective method. It is a cost effective method that requires very little maintenance. One of the drawback of plate earthing was the maintenance is high. So here you can see the maintenance is low when compared to the plate earthing. And here are some of the things to be known about the pipe earthing, like the purpose. The pipe earthing protects against the electrical hazards. It protects against the electrical hazards, reduces the electromagnetic interference. It reduces the electromagnetic interference and provides a stable reference voltage for the main system. It provides, main system is for the main circuit which is being placed inside a building or a shopping mall or a industry. So for that main circuit or for the main system, it provides a stable reference voltage. It provides a stable reference voltage. It reduces the electromagnetic interference and it reduces the electrical hazards. The second one is soil conditions. Soil conditions. The depth of the pipe depends upon the soil condition. So as I said previously, the soil condition should be detected before itself. That means it is a wet soil or like the resistance of the soil. All those things should be known before itself, and based on that we need to decide which type of earthing should be done in that particular place. So the depth of the pipe depends upon the soil condition. For ordinary soil, pipe is usually 38 mm diameter and 2.5 meters, 2.5 to 3 meters long with a diameter of 38 millimeter. For dry and rocky area, for dry and rocky soil, the pipe is usually longer. For normal soil or for wet soil, the length of the rod, the length of the pipe is less when compared to the rocky or dry soil. The third one is materials. The cast iron earthing pipes are strong and durable. Cast iron, as I said, the earthing can be done using the materials like copper, iron or steel. So mostly cast iron type of earthing pipes are strong and durable. Means the lifetime is more and can withstand the heavy loads also. We need to check the different types of loads which are being connected to this particular earthing system. So based on the maximum load capacity, we need to decide the materials also. See, the copper wires, the copper pipes are being used for earthing system because copper is good electrode due to high conductivity. That is, copper is used for good conductivity and cast iron is used for strong because it is strong and it is most durable. So both type of materials, that is copper as well as cast iron, are being used for making this pipe earthing. Next one is conductivity. To improve the conductivity, the pipe or plate is being surrounded by layers of material. In order to improve the conductivity, the pipe or plate is being surrounded by different types of materials like coke and salt. Okay. Next one is regulatory bodies. That is, pipe earthing is required by many regulatory bodies and codes. Here you can see the picture of pipe earthing, where this is the ground level. To this ground level, here you can see this is being filled with the soil, and here you can see the conductors which are being placed, and in this this is your actually pipe. The pipe, in this pipe earthing, the pipe which we are using is this one. This one is your pipe. This pipe is being filled on left as around by alternate layers of, the first layer is charcoal layer, the next layer is salt layer, again charcoal layer and salt layer. That is, alternatively we are filling the layers of salt as well as charcoal. That means, as I said, this should be placed inside the earth at a minimum of 3 meters of depth. So first we will place this particular pipe inside the earth, and that pipe is being filled around with charcoal and salt material. That is being filled with charcoal and salt material. After filling it with charcoal and salt material, we are placing the conductors, and these conductors are being again filled here with sand here, and a funnel is being placed here. And we are covering this outer part. With cast iron cover. We are covering the outer part with cast iron cover. So this is the construction of pipe earthing. Previously we used plate. Here you are using, instead of plate, we are placing a pipe here. Okay. Next type is strip earthing. Strip earthing is a method of grounding electrical appliances by passing current from them to the ground through a metallic strip. The strips are usually made up of copper or galvanized iron. Mostly they are made up of copper or galvanized iron and are installed in the depth of about 0.5 meters. Means they are being placed at a depth of 0.5 meters. So here are some tips for the strip earthing. Previously we used pipe. Now instead of pipe we are using a strip. So the first one is material. Which type of material is being used for coppers, used for strips, that is copper strips, and they are resistant to the corrosion because they are being placed inside the earth, and water may be there, soil may be having some kind of a salt. Because of that, corrosion occurs. So the copper strips should be resistant to this corrosion and provide a better voltage transient protection. They should provide a better voltage transient protection. Next one is galvanized iron. Galvanized iron are also used, but they are less effective in corrosive environments. Means they are less effective in corrosive environment. So that is a combination of copper as well as galvanized iron. Both are being used in the stripped earthing. So the second one is installation. Installation. Here the mark the root of strips. Mark the root of strip with threads and coordinate it to the other services also. Ensure there are at least 200 meters of space between the building and other services. Means the earthing system should be placed in an area where a gap of minimum 200 mm of space should be there from the building. Next one is insulation. Insulation. Cover the strips with insulating material to protect them from soil's corrosion nature. Soil will have a corrosive nature. In order to protect from the soil corrosion, cover the strips with an insulating material. And next one is length. The standard length of GI means galvanized iron earthing system, is between 7 to 10 meters. The standard length is 7 to 10 meters of length. The next one is width and thickness. Hot dipped galvanized iron strips are typically 75 to 25 mm wide and 3 to 5 mm thick. Means the strip will be in this manner, where this is 25 to 75 mm width, and the thickness here, the thickness of this material is around 3 to 12 mm. Okay, the width is 25 mm and the width minimum is 3 mm. So the next one is zinc coating. Zinc coating on galvanized strip should be at least 80 microns. The zinc coating is used for protecting it from the corrosion, soil corrosion, and the coating should be around 80 microns. So these are some of the important points about the strip earthing. So here you can see a picture of a strip. So here there are 3 strips which are being placed, and this strip length should be around 5 meters and this width should be around 25 to 75 mm. It should be around 25 to 75 mm, and the thickness here should be around 3 to 12 mm. Thickness should be 3 to 12 and width should be 25 to 75, and the length should be around 5 meters. So here you can see in the ground, inside the ground we are placing the strip here. Inside the ground we are placing the strip here. This is called as an earth pit. And this is the outer pipe. This is for protection. Protecting the strip. So a pipe is being placed. We need to first dig the earth below at least 10 meters. and after digging we need to place the pipe, and inside the pipe we need to place this strip. Okay, and after filling the pipe as well as strip, we need to fill the outer layer with salt or sand. So here you can see this is high conductor and rich material. This should be of high conducting and rich material. So this is a picture of your strip. So in this lecture we are able to know about 3 different types of earthing. That is, first earthing is plate earthing. The second one is pipe earthing. The third one is strip earthing. So here is a comparison between 3 different types of earthing. Here you can see the plate earthing. Here you can see the pipe earthing, and this one is the strip earthing. The comparison between the 3 different types of earthing. In the next lecture, I would like to tell about the requirements of commercial installation. Thank you.